Hey guys, how's it going? Just Mark here doing my assignment for Man 2300, summarizing a topic from Man 1300. The topic I've chosen is kinetics of particles and their coordinate systems. So essentially all I'll be talking about is Newton's second law. That is, F is equal to ma, sum of the forces is equal to mass times acceleration, and various coordinate systems. So just starting off with Newton's second law, say we have a ball here. We have a ball. There's a force coming in from over here. This is force 1, force coming in from over here, force 2, and another one coming over here. It's force 3. What we can do is this is just the same thing as adding all the forces together, sum of the forces in this direction, just comprising this and this and this, adding them all together, it's just going to give you this. Now this is what we call here an external force, that's a nice F there, force diagram, external force diagram. And this over here is an internal force diagram. Now, according to Newton's second law, this is exactly the same thing as the sum of mass times acceleration in that same direction. And that's it. That's all Newton's law is talking about. Now, if we start talking about the coordinate systems, there are two you mostly use in this subject, talking about kinetics of particles. We use the Cartesian coordinate system and the normal and tangential coordinate systems, and these are the ones that you use the most. There's another one called the radial and transverse coordinate system, but you don't really use it that much. It's kind of complex for this 1300, and it'll make the video way too long if I start talking about it. Now moving on to a Cartesian system. The Cartesian system here. Now, all a Cartesian system needs, it needs a reference point with a x and y axis orientation. So all that's saying is that if you had a ball here that's traveling on this path over here, with a force in this direction, sum of all the forces, that's a sigma right there. Say this is here, right here is the reference point that we're talking about, and out from here is an axis point in here. Now we're labeling this the y-axis, and this one here the x-axis. That's what we're saying. That's what we're talking about. We're saying this is our reference point here, and this is our x and y-axis orientation. Now, according to Newton's second law over here, you just a ball here again, an identical path. This is the sum of the mass times acceleration. Again, here's our reference point. Here's our positive y direction, and over here, our positive x. What we can say is that with this force, draw a line there. So with this force and this acceleration, we can say here's our force. We can break it up into the force in the x direction over here, and the force in the y direction, which is the same thing as mass times acceleration. Oh, we didn't really mean the mass times acceleration there. Mass times acceleration in the x-axis, and mass times acceleration in the y-axis. We're just breaking up this vector into two smaller vectors that add up together to give us this one. Now, what this says that the sum of the force in the x direction is just equal to the mass times acceleration in the x direction. Sum of all the forces in that direction is equal to the sum of the mass times acceleration in the x direction. We'll take an x going to the right as positive for this, and taking y going up as positive. The sum of the forces in the y direction is just the same thing as the sum of the mass times acceleration in the y direction. And that's all there is really for the Cartesian coordinate system. It's very simple. It's very lightweight. Nothing too crazy about it. Now, if we talk about our second coordinate system here, the normal and tangential coordinate system. So we have our fancy schmancy ball here again, traveling this path over here. This normal tangential system has a force coming out this way. So here's some of the forces again. Now say here, this is our path. If we draw a line out here, a line that's tangent, that's the force in the tangential direction. And over here, if we draw a line that's perpendicular at this point, it's a force in the normal direction. And just the same thing, Newton's second law, same thing we do with the Cartesian system. Here's our identical path, and our sum of the mass times acceleration. Over here, we draw a force in the tangential direction, and over here, a perpendicular force in the normal direction. Now, what we can take out from this is something a bit more complex, something with some abstract thinking, but I can't really go into it in this video over here. We're saying that some of the forces in the normal direction, taking the normal direction as positive, so kind of like this is positive, we're saying that it's equal to the mass acceleration in the normal direction, which is also equal to the mass times v squared on rho, which you may know as centripetal acceleration. Centripetal acceleration. And this over here, we have the force, some of the forces in tangential direction, taking, right over here, our tangential direction is positive. We can say that that's equal to the sum of the forces times the mass times acceleration in the tangential direction, which is also equal to mass times dv dt, because what's acceleration? It's just a change in velocity over time. That's really all there is to it in this video. Nothing too complex, nothing too out of the ordinary, and I hope it helped you. Thank you.